Good morning, everyone. In this class, we would like to know about system of equations. A linear system of m equations in unknowns will be in the form a11x1 plus a12x2 plus a13x3 plus and so on plus a1nxn is equal to b1, a21x1 plus a22x2 plus a23x3 plus and so on plus a2nxn is equal to b2 and so on am1x1 plus am2x2 plus am3x3 plus and so on plus amnxn is equal to bm. Now this is a system of m equations in n unknowns x1, x2 and so on xn. So these values x1, x2 and so on xn are also called as variables or unknowns. Here a11, a12, a13 and so on am1, am2, amn are all constants and b1, b2 and so on bm are also constants. Now this is a system of m equations in n variables x1, x2 and so on xn. Now this system can be written in matrix form as the above system in matrix form is. We write all the quotients in one matrix a11, a12, a13 and so on a1n, a21, a22, a23 and so on a2n, am1, am2, am3 and so on amn. And next we write all the variables in a column as x1, x2 and so on xn is equal to the constants on the right hand side is written in another column matrix which is b1, b2 and so on bm. This matrix is denoted with all the quotients are written in one matrix and it is denoted with the capital A and is known as coefficient matrix. All the variables written in the column matrix and this column matrix is denoted with x and this is constant, this is variable matrix. Next, all the constants written in one column as b1, b2 and so on bm and it is denoted with capital B and known as constant column matrix. So the system in the previous slide. This system in the matrix form is written like this: Ax is equal to B. All the quotients in one matrix. So this matrix is called as coefficient matrix. And it is denoted with capital X. Now X is called as variable. As it is a column matrix, you may say it as a variable column matrix. The constants on the right hand side is written in capital B and this is known as a constant column matrix. So from this system we will calculate, first of all we form an augmented matrix. So by joining all the elements of the constant column matrix to A, we will form an augmented matrix. So the augmented matrix is it is denoted with A over B, or the same can be written as A colon B. Okay. So this is equal to, next we have to add the constant column matrix to the quotient matrix. So this is A11, A12, A13 and so on A1n. As a last column we have to add the constant column matrix A21, A22, A23 and so on A2n, B2, and so on AM1, AM2, AM3, and so on AMN, BM. So this matrix is called as augmented matrix. Now we will classify the system of equations now and how to find the solutions. Okay, what type of solution the given system has. Now consider the system of equations AX is equal to B. Okay, the system of equations are of two types. One is known as homogeneous system. Another one is non-homogeneous system. So look at the system of equations. If all the elements in the right hand side are 0, that means B1 is 0, B2 is 0, B3 is 0, and so on, Bm is 0. If all the elements on the right hand side, all the constants B1, B2, and so on, Bm are all 0, then we call the system as a homogeneous system. So in this homogeneous system, Ax is equal to 0. So the right hand side column matrix is a 0 column matrix. So Ax is equal to 0. Okay. And we know that a very homogeneous system has a solution which is a trivial solution. If you take x1 equal to 0, x2 is equal to 0, x3 is equal to 0, and so on, xn is equal to 0, the given system will be satisfied. So the homogeneous system will always have a solution. If a system has a solution, then we said that the system is consistent. If a given system has a solution, we say that it is consistent. Consistent means it has a solution. So every homogeneous system is always consistent. So a homogeneous system will always have 0 solution. So it is always consistent. A homogeneous system may also have a non-zero solution. Okay. Now we'll see about the in which case the system have only 0 solution and in which case the system has non-zero solution. So here the system, the homogeneous system Ax is equal to 0 will have a 0 solution if the rank of the quotient matrix A is equal to n, which is the number of variables. If rank of the quotient matrix is equal to number of variables, rank of A is equal to n, then the system will have only 0 solution. The system may have non-zero solution if rank of A is less than n. Rank of the quotient matrix is less than the number of variables, then the system will have a non-zero solution. So here rank of A is equal to rank of quotient matrix and n is equal to the number of variables, or you can say number of unknowns. Now coming to the homogeneous system. So if all the constants on the right hand side are all 0, that means the constant column matrix is 0, then we say that the system is a homogeneous system. Ax is equal to 0. Okay, so a homogeneous system is always consistent. So it may have 0 solution. It will always have a 0 solution. In some of the cases, it may have non-zero solution also. So only 0 solution if rank of A is equal to 1. Then the system will not have any other solution if rank of A is equal to n. If rank of A is less than n, then the system will have a non-zero solution along with the 0 solution. Okay. So if rank of A is less than n, it will have two solutions at least, which is 0 solution and another one is non-zero solution. Now coming to the non-homogeneous system. That means it is in the form here B should not be equal to 0. If B is 0, it comes under homogeneous. So in non-homogeneous system, B should not be equal to 0. Now coming to the non-homogeneous system of equations. Okay, again it is of two types. The non-homogeneous system may have a solution or may not have a solution. Okay, so is it to be consistent? It may be consistent or it may not be consistent. If the system has a solution, then we say that the system is consistent. If the system does not have any solution, then we say that it is inconsistent. Now we will discuss the cases where the system of equations are consistent and where the system of equations is inconsistent. Okay, coming to the non-homogeneous system of equations. If now coming, we have already defined the augmented matrix now, and we can find the rank of the augmented matrix. If the rank of the augmented matrix is equal to the rank of the quotient matrix, okay, then the system, right? If the rank of the augmented matrix is not equal to the rank of the quotient matrix, then the system will not have a solution. Rank of A is different and rank of A over B is different. Okay, coming to consistent system, if rank of A over B, the rank of the augmented matrix is equal to the rank of the quotient matrix. So here rank of A over B is equal to rank of the augmented matrix. If the rank of the quotient matrix and rank of the augmented matrix are equal, then the system is consistent. That means it will have a solution. Now coming to the types of solutions. Again in the consistent case, that means for non-homogeneous system, if it is consistent, it may have two types of solutions. First one is a unique solution, and you know what is unique? Only one solution. Or it may have infinitely many solutions. Or it may have infinitely many solutions. Now we will discuss the cases where the non-homogeneous system has unique solution. The condition is if rank of A over B is equal to rank of A is equal to n, the number of variables. In such case, the system has unique solution. Rank of A over B is equal to rank of A is equal to n, then the system has unique solution. If rank of A over B is equal to rank of A but it is less than n, the number of variables, then the system has infinitely many solutions. Anyway, in non-homogeneous system, may be consistent or may not be consistent. If the rank of the augmented matrix is equal to rank of quotient matrix, the given system is consistent. If rank of the augmented matrix is not equal to rank of quotient matrix, then the system is inconsistent. That means it will not have solution. We can say no solution also here. So if at all both the ranks are equal, then the system may have unique solution or infinitely many solutions. Unique solution when rank of A over B is equal to rank of A is equal to n. That means rank of augmented matrix is equal to rank of the quotient matrix is equal to number of variables. But if the rank is less than the number of variables, then the non-homogeneous system will have infinitely many solutions.